In this video, I'll talk about how to find the average value of a function. Here's the problem we'll be working on. We've got a function that represents the concentration of a drug in an animal over the course of time. So our function is given by this formula, c of t equals 42.15 times e to that exponent, where t is the number of hours after the injection. So what we're being asked for is the average amount of the drug in this animal system between 15 hours and 110 hours. So before I work through the problem, I just want to explain a little bit about the method that we're going to use. So when we have a function, in this case, this concentration function is going to be a decreasing function. And we're interested in the average value from 15 to 110. So what we're going to do is we're going to find the area under that curve between 15 and 110. And at first it might not seem like area has anything to do with this problem. But what we think about here is if we find that area, the average value of this function, which is going to be some y value somewhere around there, the average value is going to be such that the area of this red rectangle that I've drawn here is the same as the blue area under the curve. And the net result of that is that the average value that we're looking for is going to be 1 divided by the base of the rectangle, which is, in this case, 110 minus 15, times the integral from 15 to 110 of my concentration function. So I'm going to integrate my function from 15 to 110 to find the area, and then I'm just going to take that value and divide it by 95. Again, where's the 95 coming from? 110 minus 15 is 95. So we'll do that integral, and then we'll divide our answer by 95, and that'll be the answer that we're looking for. Okay, so here's the integral that we're trying to solve. We want to find the antiderivative of 42.15 times e to the negative 0.01053 t with respect to t. So we're going to need to do a substitution here. So the inside function is this 0.01053 t, so that's what I'm going to call my u. So u equals negative 0.01053 t, which means du equals negative 0.01053 times dt. So that means that I'm going to need an extra factor of 0.01053 in my integral. So I'm going to insert that factor here. But then I have to put 1 over that number out front of my integral. Now I'm also going to take this factor of 42.15 and factor that out of my integral as well. So what I end up with looks like this. I've got 42.15 divided by negative 0.01053 times my integral from 15 to 110 of e to the negative 0.01053 t times negative 0.01053 dt. So all of this here, that's e to the u, and all of this here, that's my du. Now, we can work out on our calculator 42.15 divided by negative 0.01053, and that works out to be negative 4002.85. Now I'm going to rewrite my integral in terms of u's. I'm going to remind myself that the 15 and the 110 are values of t. So I get e to the u du. That's an easy antiderivative. The antiderivative of e to the u is e to the u. So I get negative 4002.85 e to the u. And again, my next step is to plug in t equals 110 and t equals 15. So I've got to plug back in what u was, 4002.85 e to the negative 0.01053 t. Now I need to plug in 110 and 15. So I've got negative 4002.85 e to the negative 0.01053 times 110. Now make sure when you type that in your calculator, you put that whole exponent in parentheses. And then minus 4002.85 times e to the negative 0.01053 times 15. And again, make sure that when you type this in your calculator, you put that exponent in parentheses. And when I work all that out, again, using my calculator, that's going to work out to be 2161.03. So that's the area under my curve. But as we discussed previously, that means that the average value is going to be that area divided by the base of that rectangle that we drew, which in this case was 110 minus 15, in other words 95. And when we work that out, we get 22.75. And the units here, if you go back and read the original problem, the units were micrograms per milliliter. So that would be our final answer.